All right, here are the solutions to free fall 2. So for this one, we just have one problem. Someone's throwing a ball straight up into the air with this initial velocity. So we're going to look at each one and do the guess method for each one. If information is the same, then we're going to write it all down again. So, looking through it, he throws the baseball straight up into the air with an initial velocity of 20 meters per second. That's the one piece of given information we have for the beginning of the problem. So that's going to be true all the way through the problem. The initial velocity for every part of this problem is going to be 20 meters per second, and it's going to be up. That's an important thing. So, first part, how high will the baseball rise after it's traveled for 3 seconds? Right away, again, we know the initial velocity is 20 meters per second up. The acceleration is 10 meters per second squared down. Because those two things disagree, we're going to make that acceleration negative. The time, looking at our problem, is 3 seconds, and our delta y, we don't know. That's what we're looking for. How high is the information we need here? So we're going to take those things. We're going to find the equation that has all that information in it. That's the delta y equals v0t plus 1/2 acceleration times time squared. We're going to plug in all of our numbers here. So delta y is equal to 20 times 3 plus 1/2 times negative 10. And again, the negative sign is very important. It's telling me we're slowing down, times 3 seconds squared. So if we do each one of those individually, we get 60 minus 45. So our delta y comes out to be 15 meters. And because it's positive, it's going to be up. All right, so for the next one, what's the maximum height of the baseball? All right, so for things that are thrown straight up, maximum height is a given piece of information. The piece of information that maximum height is, it tells me that the velocity at that point, the final velocity, is 0. So my known information this time is that the initial velocity is 20 meters per second up. That's not going to change. That's known throughout the entire problem. The acceleration is 10 meters per second squared down. Because those two disagree, we have a negative sign. The final velocity is 0 because we're at our maximum height. And what we want to know is that maximum height. So looking at this, we have a different set of knowns. So we're going to use a different equation. We're going to use the v final squared equals v initial squared plus 2a delta y equation. We're going to plug in all of our information and then solve for delta y. So what we get is 0 is equal to 20 squared plus 2 times negative 10 times delta y. It's important as we do our math that we realize that everything on that 2 times negative 10 times delta y thing is being multiplied. That's going to change. That's going to change how we solve for stuff. So I'm just going to write that again and multiply everything out. So I got 0 is equal to 400 minus 20 delta y. So I multiplied 2 and negative 10 together. So in order to solve, I'm going to subtract 400 from both sides. So that gives me negative 400 equals negative 20 delta y. I'm going to divide both sides by negative 20. The negative 20s go away on that side. 400 divided by negative 20 is 20, positive 20, equals delta y. And again, that's going to be up. How long does it take the baseball to reach its maximum height? Well, we're still talking about the same maximum height of 20 meters. So that's going to add to our givens. That's also going to tell me that we're at the maximum height and the final velocity is 0. So we have the same givens that we had before. The initial velocity is 20 meters per second up, just like it has been. The acceleration is 10 meters per second squared down. Because of that, we're going to make the acceleration negative. Because we're at the maximum height, the final velocity is 0. And because we're at the maximum height that we just found, the delta y is 20 meters. So now I can pick any equation I want to find the time. Love the first equation, so we're going to go with final velocity is equal to initial velocity plus acceleration times time. So 0 is equal to 20 plus negative 10 times t. We're just plugging all those things in. I'm going to subtract 20 from both sides. So negative 20 is equal to negative 10t. I'm just going to rewrite that. Negative 20 is equal to negative 10t. So I subtracted 20 from both sides. Now I want t by itself, so I'm going to divide both sides by negative 10. And so I have 2, positive 2, because those negative signs go away, 2 seconds is equal to the time. Part D, we have another piece of given information from our words. How long is what it's asking for, and then return to the ground is our piece of given information. There's a lot there. So returning to the ground means that delta y is 0 because that's the same as our launch position, our launch height. So if we're back at our launch height, we've made a round trip, and for that round trip, the delta y is 0. So let's write down our knowns. Here we have our initial velocity is equal to 20 meters per second up, just like it has been. And our acceleration is 10 meters per second squared down, just like it has been. So that makes it negative 10 meters per second squared. Then, continuing, our delta y is equal to 0, and we want the time. There's only one equation that has all 4 of those things in it. Delta y is equal to v initial t plus 1/2 at squared. We're going to plug our numbers in. 0 is equal to 20t plus 1/2 times negative 10t squared. Because there's a 0 there and I got a t everywhere, I'm going to eventually want to move that 20t over to the other side by subtracting it over. We're going to multiply everything out first. So 0 is equal to 20t minus 5t squared. I'm going to subtract 20t over to both sides. Right? That gets rid of it on the right-hand side. So I've got negative 20t is equal to 5t squared. Now, I want all my t's on the same side, so I'm going to divide both sides by t. But that crosses out the t's on the left side, and it crosses out one of the t's on the right side. So this leaves me with negative 20 is equal to negative 5t. Now I'm going to divide both sides by negative 5. And so that tells me the time here is equal to positive 4 seconds. If this math seems tricky to you, my advice is simple but not happy. It just takes a lot of practice. So if you're having trouble with that particular bit of math, because there are 2 t's there, we got to work on it. We just got to do lots more examples. So you come in and you talk to me about that. Last part, what's the velocity of the ball when it's at a height of 12.8 meters? So we want the final velocity, that's what we're looking for. And delta y is 12.8 meters. And that's 12.8 meters up. We're starting from the ground and we're going up. So my acceleration is 10 meters per second squared down. Those are opposites, so we got a negative sign. The initial velocity is still 20 meters per second up. What we want is the final velocity. So we got one equation. Final velocity squared is equal to initial velocity squared plus 2a times delta y. So final velocity squared is equal to 20 squared plus 2 times negative 10 times positive 12.8. So final velocity squared is 400 minus 256. Final velocity squared is 144. So I'm going to square root both sides. So the final velocity, square root both sides, is equal to 12 meters per second. But because we're taking a square root, that really could be positive 12 or negative 12. That's what math tells us we have to do with the square root. Now, what this means is, okay, so when you take a square root, you may need to write this down. The answer is both positive and negative. What this tells me physically is that we get to 12 meters per second 2 times. The ball's at 12.6 meters on the way up and on the way down. The velocity will be positive on the way up and negative on the way down. That's what it means to have plus or minus velocity. So if we look at our position versus time graph here, Right, when we launch that ball up, it's going to go up to a height of 20 meters and come back down. Looking at that graph, 12.6 meters is somewhere there. We're at 12.6 meters twice, once on the way up, once on the way down. And as you can see, the slope of that line is positive on the way up. That's my positive 12 meters per second, and it's negative on the way down. If we look at our velocity versus time graph, we start off with a positive velocity. It's going to be 0 here. It's going to be negative down here. Once we get to 12.6 meters, that's on the way up. That's on the way down. That corresponds to our up and down spots.